Hello and welcome to Space Startup News Live. I do this live stream every week at the same time. I cover the videos I posted this week, which is usually 3. I do 2 dedicated videos on a topic on a company, a startup, and then usually I do a space news, just a roundup of some space news for startups, and then I do a live stream, which I'm doing now. I go over the videos, I bring up comments from the videos, answer chat messages, and at the end I'll go over maybe some other space news, and then preview what I'm doing next week. So that's the plan. You can ask me any questions on space news in general. It's fine, and yeah, I'll try to answer. So yeah, that's the plan. So without further ado, let's get into what happened this week, or what I covered this week. So I'm going to start off with a UK company, Space Solar, and they're working on space solar satellites. That is, they're building satellites in space that capture solar energy and then beam it down to Earth, as you can see on this graphic here. And this is the actual design they're using. They've licensed this design from another UK company, and it uses 2 solar reflectors, which capture the sunlight, and then they reflect it onto the panel of solar panels, which are in like a helix shape. So the idea is that there's no moving parts, so you don't have any mechanical issues, mechanical failures. It's all like solid state. And then the actual the transmitter is also welcome, Wayne. Thank you for joining. Good to see you. Yeah, so it's solid state. There's no moving parts, no mechanical failures, and I think I said in the video, because of the scale of these things, these are very, very large satellites. It's better to have no moving parts. So yeah, and then he just beams it down directly to a place on the ground that has an antenna, a whole field of antennas, which will be kilometers in size, and that will convert the energy into electricity that's fed into the grid. And the idea is you have a whole series of these. You have a whole series of these satellites in orbit, collecting the energy and beaming it down. And it's very secure. There's a pilot beam that goes from the ground station to the satellite. It's secure, it's encrypted, and only when the satellite receives that beam does it send down the power. So, over the next 5-10 years, they'll be building these satellites, and they'll get bigger and bigger. So first there'll be a demo version, and then like a commercial size, and then like huge satellites. So the tech involved is there's if I get rid of myself here, you can see the size of these things. Here's Burj Khalifa, the largest building in the world, as Eiffel Tower, and this is the size of the smallest one, I think, which is 400 meters, and they just get bigger and bigger after that. So these are very large structures in space. But they have to be commercial. They have to be very large. But so yeah, they've got some funding. They've got a few £1 million to do the design. They have, and I didn't put this in the video. I meant to. For some reason, I didn't. They have a contract with Reykjavik Energy in Iceland, so they will be working on a small scale satellite. And I can't remember how much money they've got, but basically they got some money to work with Reykjavik Energy for their first beam demo. And yeah, they're working on the hardware. And I don't know if I've got any images of the hardware. One thing I didn't put in the video is when we talk about the orbits, there's a whole series of orbits they can do. Medium Earth orbit. You can do and you can do these weird orbits like this. The idea is that for this satellite spends most of its time in the northern hemisphere. If you look, it whips around the South Pole and then spends a long time in the northern hemisphere, which is good for like Europe or the UK or whatever. So wouldn't the Marty's saying, wouldn't the helix transmit in all directions, not just at the ground station? So the helix is just the solar panels. It's just where you convert the sunlight into energy. It's actually the transmitter, which you can't really see on the graphic, that does the beaming. So I think in the video there's some testing of the transmitter. So you've got the reflectors. If you look at the image here, you've got the reflectors at the top and the bottom. Then you've got this helix thing, which is the solar panels, and then you can't really see it because it's quite small. Is the actual transmitter, which I guess is right in the middle here, and that does the transmission. So yes, but the transmitter is able to transmit 360 degrees, and that's the key component. The key bit of technology is the 360-degree transmitter, which has been tested, so it does work. But yeah, that's a key piece of technology. And Wayne saying square cube law, Marty. But yeah, they did test out their the transmitter, and yeah, apparently it works. So that's the plan. And here's the graphic, and I'll just get rid of myself for the moment here. Here's a graphic of their plans for building the satellites. The very first one, the Merlin one, he said, the CEO said, this is the minimal viable product to be commercial. So it's 400 meters. It's going to be constructed around 2030, at the end of the decade. 30 megawatts of output, one Starship launch, and it weighs about 80 tons. Good morning, Liam. Thank you for joining. Yeah, we're just talking about space solar and solar power satellites. And yeah, Merlin is a minimum commercial viable product, and it's 80 tons and produces 30 megawatts of power, and just a single Starship launch apparently. So so I say in the video that I bring myself back up now. Myself in here, is that they're going to use autonomous robots to construct the satellite. So the solar panels go up flat packed, and you have a whole series of autonomous robots that take one solar panel from the sack and then assemble it into the helix shape. So you obviously need autonomous robots, a whole series of them, and you can slowly assemble the solar power satellite. And I think they mentioned in the documentation they can do that in low Earth orbit, and then they will move it to its operational orbit, and that could be high Earth orbit, medium Earth orbit, it could be geostationary orbit, or it could be one of these weird orbits like Molniya orbit or something like that. So there's various possibilities. So Merlin is the smallest one, but they have plans to go even bigger. They were going to do a kite in the mid-2030s, twice the size, 2 Starship launches, 160 tons, and 150 megawatts. And then they have the bigger Eagle one, probably a decade later, which is 1.4 kilometers in diameter and can produce 600 megawatts, and that requires 8 Starships. And I think the plan after that is, bring myself up, the plan after that is they'd have multiple of these all in orbit, have multiple number of those large satellites, and they pass over the ground station like you've got 3 of them every 8 hours, beaming down the power, so you can get megawatt amounts of power. And then I think they do talk about 15 gigawatt power satellites in the future, so it's just going to get bigger and bigger and bigger. Yeah, and of course you could put them around the moon as well. They don't have to be just around the Earth. So I know this is a UK company, but I know Europe is definitely interested in space-based solar power. So is China. I think Japan's also interested. So there's quite a few different countries, space agencies, and also startups working on space-based solar power. And I don't think I really covered this much in the video, but obviously with AI training models, which require enormous amounts of energy, and then you've got crypto, and you've got all of the kinds of things where the need for energy is just increasing at massive amounts. I read the other day that for the next generation of AI training models, they're going to require 5 to 6 gigawatts of power. No power station produces that amount of energy at the moment, I believe. And they take 10 years for planning and environmental, so on. So if you just put it in space, you don't have any of the environmental checks. And it's just, in theory at least, it could be a lot quicker once you have the autonomous robots, because planning things, large power stations on Earth, it just takes a very, very long time, especially in the West. Not in China, but in the West, it takes a long time. So I think we're going to space-based solar power. I think it'll be cheaper and quicker. So that's the first video, but we have some comments. Let's just bring up what people were saying, and I think I put myself in the corner on this one. So Quantum PK says, forget sending the power to Earth, never going to happen, but supporting the Moon and Mars missions in their establishment equals definitely. And someone also said, and this is quite similar, Danny Garther said, the best use case I can think of is the small version work is to put one in lunar orbit to power lunar base. So there's no reason that you couldn't push this the solar power satellite into lunar orbit, or even just assemble it in lunar orbit. Coincidentally, I'm doing a video on something like that next week. So I'll say more about that next week. And John Baza is saying, not a fan of space-based solar power. It will increase atmospheric temperature at the Earth's surface. And then in the same kind of area, Alan Niven says, this would increase global warming. And Mr. Eddie Lomax says, not if we phase out fossil fuel power generation to replace them. We have swapped gas for coal. How about space solar for gas? So, yeah. Yeah, people have different opinions on space-based solar power, but I think that it's definitely the direction, because it's just so difficult to build large power stations on Earth in the West. And for AI, we have to have more power. The next generation will use enormous amounts of power. So to compete in AI, we need the power. So I think it will come from space. And also some other comments. Wingsley is saying, and this is just an edit because there was more. He says, I see solar power satellites as an important step in both kickstarting space industry and greater space exploration. In a sense, setting up solar power satellites is the 21st century of if you build it, they will come. So basically, if you have the power, you can just do more things in space. And Marcos is saying, vamos que vamos. Thank you, Marcos, for joining. Yes, so basically, if you have the power, it will be used. So, yes. I mean, the space setups like Starcatcher that I covered that are building solar power satellites in space, and they will beam it to other satellites. That's their what the business case for them is, beaming it directly to other satellites. So multiple startups are working on beaming power in space, either to other satellites or to the ground, or perhaps to lunar habitats as well, as we mentioned. And xairforce.com says, I would like to order 1 billion for a Type 2 civilization. Please, requirement, graphene, self-replicating AI power, data communications mesh with an upgrade path to quantum communications. So there's a million different things you can do if you have the power. You can do in-space manufacturing. The startups working on that. You've got commercial space stations. You've got these communications, AI processing in space. Startups, multiple startups are working on that. Orbital data centers. So we're going to need the power. We're going to need the power in space. We're going to need it on Earth. So I think there's plenty of use cases. And Wayne is saying, wait till Starship version 5. I expect that sometime they'll increase boost ship diameter. I do as well. But first they have to get the ship to work properly. But yeah, I'm sure there'll be version 2, 3, 4, 5, and 6, and the diameter will increase. Yeah, with a bigger diameter Starship, you could launch enough solar panels, you could build a massive space power satellite in one launch. So yeah, I mean, mass to orbit is just going to increase, and hopefully the price will decrease over time. I think it's inevitable. So that is the first satellite. The first video I did this week, and Marty is saying it will be interesting if Starship launches this because Elon says space solar is worthless. He has said that in the past, but as there's more mass to orbit and the dollar per kilo goes down, at some point there's going to be a crossover where it actually makes commercial sense. I don't know when that crossover is. I know Space Solar says minimal viable product is 30 megawatts and 80 tons. And also don't forget, governments will pay for some of these satellites. The UK government, net zero, and other governments want clean, secure power. And it's just energy security as well. It's not just environmental, it's like secure energy from space. So you got that angle as well. Plus you got the like Microsoft and Facebook paying for power stations, paying for nuclear power stations, whatever, because they need all that power just for the AI, which is worth billions to them. So yeah, there's definitely use cases, and I think some companies and governments are willing to pay. So moving on to the second video this week, which is on a French space startup. I covered various French space startups already. I've covered Latitude Space, Sirius Space Services, and obviously France, the Ariane group based in France does Ariane 6 and so on. But in terms of space startups, they have a few. This is another one that I've not covered until now. Oh, before I get into that, Wayne is saying, let's look to Alberta. They put in rules which made it easier to burn fossil fuels than renewables. Short-sighted, they are burning sellable product. Yeah, the thing is, if you have secure energy beam down 24/7 baseline secure energy, you could export your gas and your fossil fuels. It is very valuable as an export. So there is advantages to having space-based solar power. And like I said, China's working on it, Japan's working on it, the European Union's working on it, and the UK has a space startup. And when you're saying, I expect, Marty, that Elon will take all paying. Yeah, I mean, they're a commercial company. They will launch whatever you want to launch. You know, they get paid whether it works or not. So, yeah, so hyperspace, which I think stands for, I say in the video what it stands for. I'm trying to remember now. It's, yeah, it's whatever it stands for. I can't remember. But basically, it's a hybrid rocket engine, which are quite rare. High Impulse in Germany is also hybrid. So basically, you have a solid fuel, and then you use some kind of oxidizer. In this case, it's liquid oxygen. So rather than having two fuel tanks, you know, your liquid fuel and your liquid oxygen and all the valves and pipes, turbo pumps, they don't have, they can get rid of a lot of that. There's no turbo pumps, and the fuel is just solid fuel grain. So it's a lot simpler. Apparently 40% of the parts they can remove. So it's going to be 40% reduction in cost. It can't explode in the same way liquid engines explode. Without a spark, there's no explosion. So that's good news. This is the orbital rocket. Yeah, and Liam's saying that there's so many European launch startups, crazy flooded market, not all of them can succeed. Would be good to see all of this funding but put into one place rather than many different players. Well, I mean, Europe funds Ariane and also the Vega. So they've got a small rocket, I think it's Italian. And then, well, it's made in Italy. It's a European rocket. And then you've got Ariane 6. So you've got two government-funded rockets. But then you've got an explosion of European space startups. There's many, many startups. Mostly, I'd say, in France and Germany. You have some in the UK. You have some in Spain. Even Italy and so on, and Poland. But Yeah, there's the European Launch Challenge, and Europe will fund a few of these, but I think there's 12 proposals, and they'll fund 2 or 3 of them, I think, to give them a little boost. So yes, anyway, this hyperspace will be launching a suborbital vehicle at the end of 2026, so next year sometime. And that will launch from France. In fact, in the video, they test at DGA, which is a missile testing site in France, and they'll be launching from there. It's on the south coast. So this vehicle is suborbital, but it can lift 300 kilos. So it's still commercial. You can lift commercial payloads. It will be suborbital. And then the year later, I don't know if I have the graphic for it here. The year later, you have the orbital version, which will put 250 kilos into orbit. And the French government has funded 5 of those launches for up to 235 kilos. So this is a micro launcher. It's very small payload, less than half the payload of the Electron from Rocket Lab, but still useful, commercially viable, maybe, depending on the price. So if the price is cheap, I'm sure they'll get customers, especially in Europe. I think someone says in the comments, I'll get to the comments later, so because I have another graphic first. And I say this in the video, the ISP is not great for these kind of hybrid engines. It's about 260 to 280 seconds. And there's 2 companies, Hyperspace High Impulse, which is German, working on this kind of hybrid engine. But they are pretty safe compared to liquid engines. In the video, I mentioned Ship 36 from SpaceX. I mentioned the RFA pad explosion. They're using liquid fuel, turbo pumps, and the turbo pump exploded and it destroyed all the engines, the first stage, and damaged the pad. So the idea with solid fuel is it's just safer. The trade-off is fuel efficiency is not as good. So it's a trade-off, right? There's pros and cons. SpaceX, the Falcon 9 is about 350 seconds. Once you get to like methane burning engines, you get to maybe 330, 380. And then the best in terms of chemical engines are liquid oxygen, liquid hydrogen, which is 450 seconds. And a lot of the Blue Origin, I mean, to give praise to Blue Origin, a lot of their vehicles are based on liquid hydrogen and liquid oxygen, which is the most fuel efficient. The New Glenn upper stage, the Cislunar transporter, and Mark 1 and Mark 2 lunar landers are all liquid hydrogen, liquid oxygen. And that ties in very nice to ISRU. That is, if you can source the propellants off-world on the lunar surface, you can power your whole transportation just using off-world resources, which I think is the plan for Blue Origin. And I've done various videos on water. That's how you move around the solar system. It's off-world sourced hydrogen and oxygen, and the Blue Origin vehicles lean into that. So anyway, that's the hyperspace. And if we bring up comments, see what people are saying about it. So Quantum PK is saying, not with the plastic. I thought we were trying to pollute the atmosphere less, not more. Grief. Hopefully 245T, which is Agent Orange, and thiolamide are rocket propellants. So that's yeah. So basically, he's not a fan of hybrids because they produce. I'll bring myself in the corner now. They produce carbon dioxide, carbon monoxide, and carbon soot. But so do RP1. Falcon 9 also produces carbon soot, and more because they're bigger vehicles. And even the clean burning methane engines still produce carbon dioxide. So they still produce pollutants. So I think it's kind of like, it's not really that much different from other rocket engines. And the hyperspace engine rocket is quite small. It's a micro launcher. So compared to the medium lift vehicles, the pollution is quite small. And also aircraft produce pollution as well. So Wingsley saying, one thing is not made clear in this presentation. Do these new hybrid rocket designs lend themselves to reusability? If they can be reused, how soon will reuse happen? When these questions are answered, the competitiveness of these new launch vehicles will become clear. And Blue Steel 8376 says, typically companies do not attempt to reuse very small rockets like the one mentioned in this video. There just isn't much financial benefit for it. Reuse becomes important in bigger rockets. So yeah, there's no point with these very small rockets. And I think for space startups, these small micro launchers are really allows them to learn how to build rockets, how to launch them, how to do the ground operations, and so on. They're just like a stepping stone to the bigger orbital launches. We've seen that with Nordspace, the Canadian launcher. We've seen that with Hyperspace, and practically all the European startups, or a lot of them, are working on a small suborbital rocket first, and then they move on to the orbital rocket, because it's just there's a learning curve, and it's easier to lose. A small rocket costs you less money, cheaper to build, and quicker. So I think that's just a stepping stone to orbital rockets. So anyway, let's move on to space startup news this week. And so I cover Exolaunch, and I say in the video I cover them quite often because they are partnering with all the space startups. This week it's Orbex, the UK space startup, are doing micro launchers. They have a rocket called Prime, and then they're building a Proxima, which is a larger rocket. So that's a UK startup. They've also partnered with PLD Space, which is Spanish, and they partnered with InnoSpace, the South Korean space startup. So they're partnering with a lot of these small rocket companies because, as they say, they want to be able to offer their customers launches on these vehicles as soon as they're available. As soon as they're in the launch market, they can offer their customers that rocket. So, which is great for the space startups. They get to use Exolaunch satellite, their CubeSats. Not CubeSats. They have these like this Exacube, and you put lots of satellites in this mechanism, and they can fire out the satellites. So they're a satellite integrator. They're like an in between the rocket launch company and the satellite customers, and they aggregate the satellites, the small satellites, and then once in orbit, they fire them all off. So that's their business plan. And so Exolaunch has another partnership with Orbex. Second is this Lux Eterna, which is a company that is building satellite buses, but these buses can come back to Earth. They can land back on Earth. The customer can get a payload, or they can get their sensors or whatever the payload is back, and then the satellite bus can be reused. So apparently this vehicle can be launched 15 times, or spends 15 years in orbit, whichever comes first. And the idea is that you can lease a payload on this satellite bus, and after a certain amount of time, you can bring it back, and then you stop paying a lease. So the idea is over time, this will be cheaper than one-off satellite buses. And the CEO worked at SpaceX. He was a Starlink engineer, and he's saying reuse is just cheaper than building brand new satellite buses each time. So they got $4 million in pre-seed funding. So they're very small. They just come out of stealth, and so we'll see what happens. And then I also mentioned ICE Aerospace. If you're familiar, this is ICE Aerospace. I believe this is the very first, if I put in all the caveats, it's the very first commercial space startup in Western Europe that have launched an orbital rocket. It only lasted for 30 seconds and then it crashed, but still, it launched. And ISA Aerospace is well funded. They've got another 150 million euros from a US company, a US venture capital company. And they now have 550 million euros. So I think they are the most well-funded space startup in Europe. And they're working on the second and third launcher. This is the first one, and did work. But this is, for space startups, failing on the first time is almost guaranteed. There's practically no space startups that can build an orbital vehicle and it work the very first time. It's unheard of. So the fact it's failed is no big deal. It's expected. They have hardware already. They were building hardware for Flight 2 and Flight 3 even before Flight 1. They're very well funded, so I think they have a good chance of succeeding eventually. So hopefully Flight 2 is later this year. We have RFA, Rocket Factory Augsburg, that could be launching later this year, another German company. So I'd say ISA Aerospace and RFA are neck to neck. They're very close, both of them, to launching the next vehicle. And then you've got PLD Space and you've got some other European companies. So there's like a race for the first Western or the first European space startup. So that is space news. What else did I want to bring up? So in terms of other space startup news, there's obviously, Axiom 4, they're on the International Space Station now. They're there for like a week or so, and then they're coming back. And what else is there? Vast Space is continuing to test all their hardware, and they're launching maybe next year. It was supposed to be this year, but they're launching a Falcon 9 next year, I think, maybe April, something like that. So that will be the very first commercial space station. And so that is the space news this week. In terms of what I'm doing next week, I'm going to do something about power satellites orbiting the moon to power lunar habitats. There were some comments this week about doing that, and I had planned to do a video for a while. In fact, I planned it so I do space solar first to bring up solar power satellites around Earth, and then I'm going to do one on having them around the moon to power lunar habitats. So that's my first one, and the second one I have an idea what I'm going to do next week, but I'm not certain at the moment. So yeah, I definitely have more videos to do on lunar habitats. There's some other ideas, plans I want to cover. So that's the plan. So thank you for joining this week, this live stream, and I do this every week at the same time. So I cover typically the videos I've done this week, which is usually 3 videos, 2 on dedicated companies or plans, and then a roundup on space news. I bring up comments people leave on the videos and answer chat messages. So thank you for joining, and I will see you next week. Okay, bye.